Mars, the red planet, has fascinated humanity for centuries. From ancient civilizations tracking its blood red glow in the night sky to modern missions landing rovers on its dusty surface, Mars has always been a place of mystery and intrigue. But here's the thing, even with all our cutting-edge technology, with orbiters mapping its surface and robots drilling into its soil, Mars still refuses to give up its secrets. In fact, scientists have catalogued not just one or two, but 30 baffling phenomena that defy explanation. Strange lights flicker in its atmosphere. Unexplained geological formations stretch across its deserts. Anomalies that shouldn't exist, yet there they are, staring back at us, daring us to figure them out. What if I told you some of these mysteries could rewrite everything we think we know about Mars? Picture this. A landscape where rocks move on their own, where towering plumes of gas erupt without warning, and where structures that look eerily artificial dot the terrain. These aren't just random oddities, they're clues, pieces of a puzzle that could reveal whether Mars was once alive, or if it still hides secrets beneath its barren surface. And the most chilling part, we've only scratched the surface. Every new mission, every fresh image seems to uncover something even more perplexing than the last. So today, we're diving deep into these enigmas. We'll explore the 30 most head-scratching, spine-tingling phenomena on Mars, the ones that have even the brightest scientists struggling for answers. Some might be natural quirks of a harsh world. Others, well, they might just make you question whether we're truly alone in the universe. Buckle up, because what you're about to discover will leave you wondering, is Mars trying to tell us something? Or are we just beginning to understand how little we actually know? Let's begin. The first mystery on our list is one that sparked imaginations and conspiracy theories around the world. In 1976, NASA, a Viking 1 orbiter, captured an image of a region on Mars called Pareidolia, and what it showed seemed too bizarre to be real. A massive formation, nearly 2 miles long, stared back at the camera with what looked like 2 hollow eyes, a nose, and even a faint suggestion of a mouth. The media immediately dubbed it the face on Mars, and speculation ran wild. Could this be evidence of an ancient civilization, a monument left behind by some long-lost Martian builders? The public's reaction was electric, with some convinced we'd found proof of intelligent life beyond Earth. But science, as it often does, stepped in with a more down-to-earth explanation. When later missions like Mars Global Surveyor and Mars Reconnaissance Orbiter returned high-resolution images of the same spot, the so-called face crumbled, quite literally, into a trick of light and shadow. What once appeared sculpted now looked like nothing more than a weathered mesa, its human-like features vanishing under sharper scrutiny. Yet, even with this debunking, the face on Mars never really faded from popular culture. And that's where psychology comes in. Our brains are wired to recognize faces. It's called pareidolia, the same phenomenon that makes us see shapes in clouds or the man in the moon. That instinct is so strong that even when we know better, part of us still wants to believe. Of course, not everyone accepted the official explanation. Conspiracy theorists argued the later images were doctored, claiming NASA was covering up the truth. Books, documentaries, and even fictional stories kept the myth alive, transforming the face into a symbol of cosmic secrecy. And honestly, that lingering fascination tells us just as much about us as it does about Mars. We project our hopes, fears, and curiosity onto that barren landscape, always searching for something or someone looking back. The face may be just a rock, but the mystery it represents, that's very real, and it's the perfect introduction to the even stranger enigmas still waiting on Mars. Now, let's move from an optical illusion to something far more tangible: tiny, mysterious objects scattered across the Martian surface like nature's own marbles. When NASA Opportunity rover rolled across the plains of Meridiani Planum in 2004, its cameras spotted something bizarre: countless small, spherical rocks littering the ground. Scientists quickly nicknamed them Blueberries, not just for their shape but for their bluish-gray hue against Mars' rusty landscape. But these weren't just pebbles, they were hematite concretions, tiny balls of iron oxide minerals, and their presence was a scientific goldmine. Hematite usually forms in the presence of liquid water, so these blueberries became one of the strongest early clues that Mars once had a watery past. Picture shallow lakes or groundwater slowly seeping through porous rock, leaving behind mineral deposits that over eons eroded out and rolled free. That's the leading theory anyway, but here's where things get weird. These spheres are too perfect. They're nearly identical in size, most no bigger than a BB pellet, and they're scattered with eerie uniformity, almost like they were deliberately placed. Naturally, that kind of strangeness invites wilder theories. Some researchers have wondered if they could be fossilized microbial structures, tiny remnants of ancient Martian life preserved in iron. Others, leaning into pure speculation, have floated the idea that they're manufactured objects, remnants of some long-lost technology. Skeptics, of course, point out that nature loves symmetry too. Similar concretions exist on Earth, like the Moqui marbles in Utah. But even those don't match the Martian blueberries' uncanny consistency. What makes these little spheres so compelling isn't just their origin story, it's what they represent. They're a reminder that Mars doesn't play by Earth's rules. Processes we think we understand might unfold differently there, bending our expectations. Every time we find something familiar, like a mineral we recognize, Mars twists it just enough to keep us guessing. And that's the real magic of these blueberries. They're both a clue and a riddle, a signpost pointing to Mars' watery past while still hiding a few secrets in their polished, enigmatic forms. If Mars has taught us anything, it's that the planet has a habit of revealing its mysteries in fleeting, almost teasing ways. Take the Recurring Slope Lineae, those enigmatic dark streaks that slither down Martian slopes like ghostly fingers reaching toward the valleys below. These aerosels, as scientists call them, appear and vanish with the seasons, darkening and lengthening during warmer months before fading away when temperatures drop. At first glance, they look like the telltale signs of liquid water, salty, briny flows seeping just beneath the surface, staining the soil as they trickle downhill. And that possibility, it's electrifying, because where there's liquid water, even if it's just a trickle, there could be life. The leading theory paints a picture of Mars as a world not entirely dead, just hiding its secrets well. These streaks could be evidence of subsurface aquifers or perchlorate salts pulling moisture from the thin Martian air, creating just enough liquid to darken the soil as it oozes downward. The chemistry fits. Mars is known to have salt deposits, and perchlorates can lower water's freezing point, allowing it to stay liquid in frigid conditions. But here's the twist. When NASA Mars Reconnaissance Orbiter analyzed these streaks with its spectrometer, it found no direct evidence of water. Instead, the darkening might be caused by shifting grains of sand or dust, cascading in dry avalanches triggered by seasonal changes in temperature. So which is it, water or wind? The debate rages on, and both sides have compelling arguments. Proponents of the water theory point to Earth's own deserts, where similar streaks form from intermittent water flow. Opponents counter that Mars' ultra-dry environment makes liquid water unlikely, even with salts in the mix. And then there's the wild card. Could these streaks be the work of something else entirely? Some researchers have proposed that underground pockets of carbon dioxide, thawing and expanding, might be pushing soil downhill in gas-lubricated slides. The implications are massive. If aerosols are caused by liquid water, even in tiny amounts, they'd be prime targets in the search for Martian microbes. Life as we know it needs water, and these seasonal flows could be the last refuge of organisms clinging to existence beneath the surface. But if they're just dry landslides, that doesn't rule out life altogether, but it does mean Mars is even harsher, even drier than we'd hoped. And that's the thing about Mars, just when we think we've got it figured out, it throws us another curveball. These streaks are more than just geological oddities. They're a reminder that the red planet still has secrets to spill, and we're only beginning to decode them. One of the most tantalizing puzzles on Mars isn't something we can see, it's something we can smell. Methane, a gas that on Earth comes from everything from cow digestion to rotting plants, has been wafting through the Martian atmosphere in sporadic, unpredictable bursts. The Curiosity rover first detected it in 2013, and what followed was a scientific detective story full of twists, dead ends, and renewed hope. Here's the kicker: methane shouldn't stick around for long in Mars' thin air. Sunlight and chemical reactions should break it apart within a few hundred years, so when we detect it, that means something recent is producing it. The question is, what? The most thrilling possibility: microbial life. On Earth, the vast majority of methane comes from living organisms, from bacteria churning away in wetlands to the digestive systems of termites. If microbes exist, or existed beneath Mars' surface, they could be releasing this gas as a byproduct of their metabolism. Imagine colonies of tiny organisms huddled in briny pockets deep underground, quietly exhaling methane that occasionally seeps up through cracks and vents. It's a scenario that sends shivers down the spine of astrobiologists. But before we get too excited, there's another contender: geology. Processes like serpentinization, where water reacts with certain minerals, can produce methane without any life involved. Mars' volcanic past and mineral-rich crust make this a strong possibility. And here's where the mystery deepens: the methane doesn't behave as expected. Curiosity's readings show wild fluctuations, with concentrations sometimes spiking tenfold before vanishing entirely. Orbiter data, meanwhile, has been contradictory, with some instruments detecting global methane plumes while others find nothing at all. This inconsistency has scientists scratching their heads. Is methane being destroyed faster than we thought? Are local geological conditions trapping or releasing it in unpredictable ways? The Rosalind Franklin rover, set to launch in the coming years, could finally crack this case. Equipped with a next-generation drill and lab tools, it's designed to analyze Martian soil for organic compounds and, crucially, to distinguish between biological and geological methane. The stakes couldn't be higher. If the rover finds evidence linking methane to life, it would be one of the most profound discoveries in human history. But even if the answer turns out to be purely geological, the mystery itself reveals how little we understand Mars' hidden chemistry. Methane is more than a gas, it's a ghost flickering in and out of view, daring us to follow its trail. And one way or another, we will. Just when we thought Mars couldn't get any stranger, it served up a cosmic pastry. In 2014, NASA Opportunity rover, after a decade of rolling across the Martian wilderness, transmitted an image that sent the internet into a frenzy. There, sitting on the rusty soil like a dropped breakfast, was a pale, almost perfectly circular rock with a hole in its center. The so-called Martian donut looked so out of place, so deliberate, that even scientists did a double take. How did this oddity appear in a spot the rover had photographed just days before, where no such rock had existed? NASA's explanation was simple, if a bit unsatisfying. The rock, dubbed Pinnacle Island, was likely a fragment knocked loose by the rover's wheels as it maneuvered. The white color, just the underside of a rock that had been buried, its dust-free surface contrasting sharply with the weathered landscape. Case closed, except of course it wasn't. The internet, ever eager for cosmic intrigue, had other ideas. Some speculated it was a meteorite, its smooth shape carved by atmospheric entry. Others went further, suggesting it might be debris from some long-lost Martian structure, or even, yes, really, an alien artifact. The fact that it resembled a jelly donut only added fuel to the fire, with jokes about interplanetary bakeries trending worldwide. What makes this donut rock so fascinating isn't just its bizarre appearance, it's the way it highlights humanity's irresistible urge to find meaning in the unknown. We see a round rock and suddenly it's evidence of a civilization. A shadow becomes a face, a streak on a hillside becomes a river. Mars, more than any other planet, invites this kind of storytelling. It's close enough to feel familiar, yet alien enough to keep us guessing. And while scientists may shrug and say, it's just a rock, the rest of us can't help but wonder, what if it's not? The truth is, Pinnacle Island is special, just not in the way conspiracy theories suggest. Its sudden appearance gave researchers a rare glimpse at pristine Martian material, untouched by surface weathering. Analysis revealed it was rich in sulfur, magnesium, and manganese, clues to the planet's geological history. But here's the kicker: even with all the data, no one can say for sure exactly how it formed. Was it ejected by an ancient impact shaped by water long ago? The donut rock, for all its silliness, is a reminder that Mars still has surprises lurking in plain sight. And sometimes the most ordinary-looking things turn out to be the most extraordinary puzzles. The Martian landscape has given us no shortage of optical illusions, but few have captured the public imagination quite like the so-called jelly donut UFO. In 2014, NASA Curiosity rover snapped an image that sent conspiracy theorists into overdrive. A shiny, disc-shaped object perched on a rock outcrop, glinting in the sunlight like a metallic saucer straight out of a sci-fi flick. The object's smooth, almost polished appearance stood in stark contrast to the rough, rust-colored terrain around it, and within hours, the internet erupted with claims that Curiosity had stumbled upon definitive proof of extraterrestrial technology. Scientists, of course, were skeptical from the start. Close examination revealed the UFO was likely nothing more than a trick of light, a lens flare caused by the sun striking the rover's camera at just the right angle. On Earth, lens flares are common in photography, appearing as bright circles or streaks when light reflects inside the camera lens. Mars' thin atmosphere and dust-filled skies can amplify these effects, creating artifacts that look eerily artificial. But here's where it gets interesting. The object's shape and position matched precisely with where a lens flare would appear given the sun's location at the time of the photo. Even the color gradient shifting from bright white to a faint blue, aligned with known flare patterns from Curiosity's mastcam. Still, not everyone was convinced. Some argued the object appeared in multiple frames, suggesting it wasn't just a transient glitch. Others pointed to similar UFOs spotted in other rover images, shiny dots or disks that seemed to hover above the surface. Planetary scientists countered that these, too, were likely camera artifacts or even bits of debris from the rover itself. After all, Curiosity's descent stage had scattered hardware across the landing zone, and wind could have carried reflective fragments far and wide. The Jelly Donut UFO episode underscores a broader truth about Mars exploration. The human brain is wired to seek patterns, especially in unfamiliar environments. Combine that with the limits of robotic cameras, fixed lenses, fixed angles, no ability to walk over and inspect things firsthand, and you've got a recipe for misinterpretation. Every shiny rock becomes a spaceship, every shadow becomes a structure. It's the same impulse that turned a mesa into the face on Mars or made blueberries seem like alien artifacts. But beyond the debate over this one strange image lies a deeper lesson. Mars is a world of extremes: blinding sunlight, deep shadows, dust storms that scatter light in unpredictable ways. These conditions don't just challenge our rovers, they challenge our perceptions. What looks like a UFO one day might be a pebble the next, and that's the real value of these mysteries. They force us to question, to scrutinize, to learn the difference between a discovery and a mirage. Because on Mars, the truth is often hiding in plain sight, if only we know how to look. If there's one thing Mars excels at, it's playing tricks on the human eye. and few illusions have sparked as much wild speculation as the so-called crab monster of 2015. The image captured by Curiosity rover showed a shadowy alcove in a rock formation, and nestled within it was a shape that looked uncannily like a crouching crustacean, complete with what appeared to be legs, a segmented body, and even claws. The internet exploded. Had we finally found proof of Martian life? Was this some ancient creature fossilized in its hiding place, or worse, was it still alive? The answer, unsurprisingly, lies in the quirks of human perception. This is Pareidolia at work again, the same psychological phenomenon that made us see a face in Cydonia or a donut on the plains. Our brains are hardwired to spot familiar patterns, especially ones that might signal danger or opportunity. On Earth, we've fallen for similar illusions countless times. The Mars rat, a tiny rock in another Curiosity image that looked like a rodent mid-scurry, or the countless Bigfoot sightings that turn out to be twisted tree trunks or shadows. The crab monster is just Mars' latest addition to this hall of fame of misidentification. But why does this keep happening? Part of it is sheer enthusiasm. The idea of life on Mars, past or present, is intoxicating. Every strange rock or shadow feels like a potential clue, a breadcrumb leading us closer to answering one of humanity's biggest questions: are we alone? And Mars, with its eerie landscapes and haunting silence, is the perfect canvas for our projections. We want to see creatures in the cracks, cities in the cliffs. It's not just conspiracy theorists either. Even scientists occasionally catch themselves doing a double take when a rock formation looks a little too symmetrical or a shadow a little too deliberate. The crab monster, when examined closely, is just a wind-sculpted rock, its crab-like silhouette carved by millennia of dust storms and temperature swings. But the real story here isn't about what the rock isn't, it's about what it represents. This tiny moment of collective wonder reveals something profound about our relationship with Mars. We're not just exploring a planet, we're searching for connection, for a universe that feels less lonely. Every monster we imagine, every face we spot, is a testament to that longing. And who knows, one day we might just be right. Until then, the crab monster remains a charming reminder. Mars might be barren, but our curiosity about it never will be. One of the most striking images ever sent back from Mars shows a formation so geometrically perfect, it seems sculpted by hands, not nature. In 2015, NASA, a Curiosity rover, photographed a rock unlike any other in its travels, a near-flawless pyramid, its triangular faces rising sharply from the Martian soil as if placed there by some ancient architect. The internet predictably erupted. Here at last was proof, or so the claims went, that Mars once harbored an advanced civilization, one capable of engineering feats rivaling Earth's Great Pyramids. Conspiracy theorists drew lines between Giza and the Red Planet, suggesting a lost interplanetary connection. But before we start rewriting history, let's take a closer look at this so-called Martian pyramid and why it's far more fascinating as a natural wonder than an alien artifact. First, the scale. Unlike Egypt's monumental pyramids, this Martian version is tiny, barely the size of a car hood. High-resolution images reveal its surfaces are rough and pitted, weathered by eons of wind and dust storms. What makes it appear so unnaturally symmetrical is a trick of perspective. The rover's camera caught it at just the right angle, with sunlight emphasizing its clean edges against the barren landscape. From another viewpoint, it's clearly just another rock, albeit one shaped by Mars' relentless erosion. And that's the key. Mars is a master of geological origami. On Earth, we see similar shapes in places like the Moeraki boulders of New Zealand, spherical rocks that seem too perfect to be natural, yet are formed entirely by mineral deposition and erosion. On Mars, the process is even more extreme. With no vegetation or water to soften the landscape, wind sculpts exposed rock into sharp angles, flat plains, and even near-perfect geometric forms. Add to that the planet's lower gravity, which allows finer dust particles to settle and compact in ways that amplify these shapes over time. The result: rocks that look designed but are really just nature showing off. Still, the question lingers, could there be a hint of truth to the pyramid hype? Some scientists have floated a compromise. While the pyramid isn't artificial, its shape might hint at something equally thrilling: ancient volcanic activity. On Earth, pyramidal formations like Devil's Tower in Wyoming were formed by cooled magma fracturing into columnar joints. If Mars' pyramid shares a similar origin, it could point to a more geologically active past than we've assumed. Or it might simply be a piece of harder rock left standing as softer material eroded away. A geological oddity, but not an unnatural one. The real lesson of the Martian pyramid isn't about aliens or lost civilizations. It's about how easily our minds impose order on chaos, seeing intention where there's only chance. Every time we project our own stories onto Mars' rocks, we miss the planet's true marvels: the way its winds carve art from stone, the way its geology defies expectation, the way it reminds us that nature doesn't need a blueprint to create the extraordinary. The pyramid isn't proof of Martians, it's proof that reality, when left to its own devices, can be stranger than fiction, and that's a mystery worth savoring. Among the countless dunes rippling across Mars' vast deserts, one stood out in a way no one could have predicted: a perfect, sprawling emblem straight out of science fiction. In 2019, NASA Mars Reconnaissance Orbiter captured an image of a dune field in the planet's southeastern region, and there it was, a near-perfect replica of the iconic Starfleet insignia from Star Trek, etched into the rusty sand as if by cosmic fan service. The symbol, spanning over a kilometer wide, boasted the familiar arrowhead shape with a tapered tail, its crisp edges contrasting sharply against the surrounding terrain. Unsurprisingly, the internet exploded. Trekkies declared it fate, conspiracy theorists whispered about clandestine NASA tributes, and even casual fans couldn't resist the eerie coincidence. Scientists, of course, were quick to explain the phenomenon, and the truth is almost as cool as the fantasy. The symbol wasn't the work of interstellar Starfleet cadets, but the result of Mars' relentless wind patterns sculpting the dunes over millennia. Here's how it happened: a series of crescent-shaped Martian dunes, common on both Mars and Earth, had migrated across the landscape. As they drifted, their trailing arms merged and elongated, while a natural depression in the terrain, likely an ancient impact crater, guided the wind to carve out the emblem's distinctive center notch. The result: a fleeting alignment of geology and fluid dynamics that, from orbit, looked like a deliberate nod to Star Trek's vision of space exploration. But let's be honest, the real magic of this discovery isn't just in the science. It's in the delight it sparked. For a brief moment, the boundary between fiction and reality blurred, and people everywhere reveled in the whimsy of a universe that seems to wink back at our pop culture myths. Even NASA leaned into the fun, tweeting a cheeky reference to Star Trek's mission to boldly go where no one has gone before. And why not? Science has always thrived on imagination. The same spirit that dreamed up warp drive and phasers now fuels our very real quest to reach Mars. That said, the Starfleet dune isn't just a cosmic inside joke. Its formation holds real clues about Mars' ever-shifting surface. The precision of the shape reveals how finely tuned wind currents are on the red planet, where a whisper-thin atmosphere can still move mountains of sand over time. Similar dune fields elsewhere on Mars show bizarre formations, clusters of dots, spirals, even what looks like Morse code, each a fingerprint of the planet's unique weather patterns. The Starfleet symbol just happens to be the one that speaks to us, a reminder that exploration isn't just about data and drills. Sometimes it's about stumbling across something that makes us smile and wonder at the universe's sense of humor. So, is this a sign that Star Trek predicted humanity's future on Mars? Probably not. But in a way, that's missing the point. the real takeaway is how effortlessly Mars mirrors our collective dreams, how a simple quirk of geology can feel like a message from the cosmos. Whether it's a face, a pyramid, or a pop culture icon, the red planet keeps offering up riddles wrapped in layers of dust and desire. And maybe, just maybe, that's exactly what makes it so irresistible. In 2014, NASA Curiosity rover sent back an image that made even seasoned scientists pause, a rock formation so eerily reminiscent of a human femur that it sparked instant debate. There it was, lying in the dust, complete with what appeared to be a rounded head, a tapered shaft, and even subtle ridges resembling bone texture. The internet predictably went wild. Had we stumbled upon the remains of a long-lost Martian giant? Or worse, was this proof of some ancient, unthinkable connection between Earth and Mars? The truth, as always, is both simpler and stranger. Mars' environment makes the existence of complex life, let alone bipedal, human-like creatures, virtually impossible. The planet's thin atmosphere, relentless radiation, and lack of liquid water for billions of years create conditions far too harsh for multicellular organisms to evolve. Even if life did emerge in Mars' distant past, it would almost certainly have been microbial, tiny organisms clinging to ephemeral pockets of moisture. A femur-sized fossil, that's not just unlikely, it's a geological impossibility. So what are we looking at? The bone is a textbook example of Pareidolia, our brain's habit of imposing familiar shapes on random patterns. Wind erosion, freeze-thaw cycles, and chemical weathering can sculpt rocks into uncanny mimics of organic forms. On Earth, we see this in places like South Dakota's Badlands, where erosion carves spires that look like castle towers or faces. Mars, with its unrelenting winds and lack of vegetation, takes this sculpting to extremes. The femur is just another casualty of our overactive imagination, a rock worn down by millennia of Martian sandblasting. But here's where things get interesting. While this particular bone is a bust, the idea of fossil hunting on Mars isn't entirely far-fetched. If microbial life ever thrived there, its traces might still be hiding in the rocks, just not as dinosaur-sized relics. Future missions like the Mars Sample Return Campaign could drill into ancient lake beds or hydrothermal vents, places where microbes might have congregated. The key will be looking for subtler clues, microscopic textures, chemical signatures, or even tiny structures called stromatolites, which on Earth are layered mounds formed by bacterial colonies. The femur rock, for all its viral fame, teaches us a crucial lesson about Mars exploration. Our hopes and fears shape what we see, often overshadowing the quieter, more profound mysteries waiting to be uncovered. The real treasure won't be a bone or a statue. It might be a speck of carbon, a whiff of organic molecules, or a pattern in the dirt too small for the naked eye. And when we find that, it won't just rewrite Martian history, it'll redefine our place in the cosmos. So while the alien femur is just a rock, the curiosity it ignited is anything but. It's a reminder that Mars, for all its barren beauty, is still a world of surprises, and the greatest discoveries may be the ones we haven't even thought to look for yet. In 2012, something extraordinary happened above Mars, something so bizarre that astronomers initially doubted their own instruments. Amateur stargazers and professional observatories alike reported seeing massive plumes towering over the planet's surface, some stretching up to 250 kilometers into the sky. To put that in perspective, these formations were taller than any cloud or storm system ever recorded on Earth, reaching heights where Mars' atmosphere practically fades into the void of space. Even more puzzling, the plumes reappeared in 2015, lingering for days before vanishing as suddenly as they'd appeared. This wasn't just a weather event, it was a full-blown atmospheric anomaly, one that still has scientists scrambling for answers. So what could possibly create such colossal structures in Mars' whisper-thin air? The leading theory points to carbon dioxide ice clouds, On Mars, CO2 makes up most of the atmosphere, and under the right conditions, it can freeze into tiny ice crystals high above the surface. Sunlight reflecting off these crystals might explain the plume's brightness, but there's a catch. These clouds usually cap out at around 100 kilometers. The plumes smashed that ceiling, soaring more than twice as high as any known Martian cloud formation. That discrepancy has researchers questioning whether some unseen process, maybe intense updrafts or electrostatic forces, could be lofting ice particles into unheard-of altitudes. Then there's the aurora hypothesis. Earth's northern lights occur when solar particles collide with our magnetic field, but Mars lost its global magnetic shield billions of years ago. Instead, it has patchy remnants of magnetism locked in certain rocks. If solar radiation hit one of these localized fields just right, could it trigger a uniquely Martian light show? Some scientists think so, suggesting the plumes might be glowing auroras on a scale we've never witnessed. Problem is, auroras typically don't form cohesive, towering structures. They're more like diffuse curtains of light. The plume's defined shapes don't quite fit, and then the elephant in the room, volcanoes. Mars is home to Olympus Mons, the solar system's largest volcano, though it's been dormant for millions of years. Could these plumes be signs of unexpected activity? Even a faint burp of geothermal gases could send material skyrocketing in Mars' low gravity. But here's the wrench in that theory. No orbiting spacecraft detected heat signatures, ash or sulfur dioxide, the usual fingerprints of an eruption. Unless Martian volcanoes operate on entirely different rules, this seems unlikely. What makes these plumes so captivating isn't just their mystery, it's what they reveal about how little we understand Mars' atmosphere. Our models can't fully explain how such massive features could form, persist, and then disappear without a trace. Every proposed solution feels like trying to fit a square peg into a round hole. Are we missing a fundamental process? Could Martian weather have a trick up its sleeve that defies Earth-based logic? The plumes are a humbling reminder that Mars, even after decades of exploration, still holds cards close to its chest. And that's the thrill of it, because somewhere in those towering enigmas might lie clues to a bigger truth about the red planet's hidden workings. For now, the plumes remain one of Mars' most tantalizing maybes. They're a cosmic wink, a challenge thrown down to scientists and dreamers alike. Figure me out if you can. And with every new mission, every sharper-eyed telescope, we get closer to doing just that. Until then, they stand, quite literally, as monuments to the enduring mystery of Mars. Mars isn't just a static desert, it's a world in motion, and nothing proves that better than the breathtaking spectacle of its avalanches. NASA's high-rise orbiter has captured jaw-dropping footage of these events. Towering cliffs of dust and ice collapsing in slow motion, sending massive plumes billowing across the landscape like silent explosions. These aren't your typical snowslides, they're avalanches of fine Martian regolith, sometimes mixed with carbon dioxide frost, cascading down slopes at speeds of up to 100 kilometers per hour. The result, otherworldly streaks of dark debris stretching for kilometers, painting the terrain with temporary scars that fade over months as winds redistribute the dust. The trigger for most of these avalanches is as predictable as it is fascinating: the changing of the seasons. When Mars tilts toward the sun, frozen carbon dioxide coating the polar regions and mid-latitude cliffs begins to thaw. This isn't a gentle melt, it's a violent transformation. CO2 ice doesn't turn to liquid, it sublimates directly from solid to gas, building pressure beneath the surface until the overlying layers can't hold back anymore. The result, a sudden, explosive release that destabilizes entire slopes, sending cliffsides sliding into the valleys below. It's like popping the cork on a champagne bottle, except the cork is 1,000,000 tons of dust, and the bottle is a 200-meter-high Martian escarpment. But here's where the mystery creeps in. While most avalanches align with this seasonal thaw, some defy the pattern entirely. High Rise has documented slides in regions where CO2 frost shouldn't be present or during seasons when the ice is stable. Even stranger, a handful occur on slopes that face away from the sun, places where solar heating should be minimal. These outliers have scientists rethinking the mechanics of Martian landslides. Could underground gas vents be destabilizing slopes from within? Are quakes from meteor impacts or shifting tectonic plates playing a role? Or is there some hidden process, something we haven't even considered, that's sculpting these cliffs behind the scenes? The implications stretch beyond pure curiosity. Understanding these avalanches is crucial for future Mars missions. Landing near steep terrain could mean placing a rover or habitat in the path of a potential slide, and without warning, a single cascade could bury equipment under meters of debris. But there's an opportunity here too. Avalanche tracks expose fresh layers of soil, giving scientists a free sample of subsurface material without needing to drill. Some researchers even speculate that these slides might uncover pockets of ancient ice or traces of organic compounds, preserved beneath the surface for eons. What makes these avalanches more than just a geological curiosity is what they reveal about Mars as a living, breathing world, not in the biological sense but in its constant state of change. Earth has its rivers and rain, Mars has its dust storms and CO2-driven landslides. Both planets are restless, reshaping themselves in ways that remind us no landscape is truly frozen in time. The avalanches are a spectacle, yes, but they're also a lesson in humility. Every time we think we've mapped Mars' rules, it throws us a curveball, proving that even a planet with a whisper-thin atmosphere still has the power to surprise. Mars has a way of playing tricks on our eyes and our fears, and few images prove that better than the infamous Mars ghost. Back in 2008, NASA's Spirit rover sent back a photo that sent chills down spines worldwide. There, perched on a rocky outcrop, stood a shadowy figure with what appeared to be outstretched arms, its silhouette uncannily humanoid against the rusty landscape. The internet, ever eager for a cosmic horror story, immediately declared it proof of Martian phantoms, or worse, an alien observer silently watching our rover from the cliffs. The timing was almost too perfect, with the image surfacing just weeks before Halloween, fueling endless campfire-worthy tales of a haunted red planet. But let's pull back the curtain. The ghost is almost certainly just a trick of light and perspective. A jagged rock catching the sun at just the right angle to cast a distorted, elongated shadow. Spirit's cameras, positioned low to the ground, exaggerated the shape, making it loom like a specter over the terrain. Scientists point out that the rover's own tracks are visible nearby, proving it had already passed this spot without encountering any supernatural hitchhikers. And yet, the eeriness lingers. Why? Because our brains are hardwired to see human forms in ambiguity, a survival instinct that once helped us spot predators in the dark. On Mars, where every shadow could hide a secret, that instinct runs wild. The real fun of the Mars ghost isn't in debunking it, though, it's in leaning into the spectacle. Imagine the scene, a lonely rover rolling through a silent wasteland under a pale pink sky when suddenly something watches back. It's the stuff of classic sci-fi, a moment that taps into our deepest anxieties about the unknown. And Mars delivers that thrill better than any haunted house. After all, this is a planet where the sunsets are blue, where dust devils tower like skyscrapers, and where the very air is toxic. If any world deserves a ghost story, it's this one. So while the ghost may just be a rock, its legacy is anything but ordinary. It's a reminder that exploration isn't just about data and discoveries, it's about the stories we tell along the way. Whether it's a shadow on a cliff or a whisper in the wind, Mars keeps giving us just enough mystery to keep us hooked. And who knows, maybe one day we'll find a mystery that doesn't have an explanation. Until then, the Mars ghost stands or floats as a tribute to the red planet's talent for keeping us deliciously on edge. In the vast, wind-scoured plains of Mars, rocks don't just sit idly, they perform. Case in point, the so-called Martian lizard, a tiny, glossy formation captured by Curiosity's massed camera in 2013 that sent the internet into a frenzy. There it was, crouched on a ledge, a reptilian silhouette with a seemingly arched back, tapered tail, and even textured skin, glinting in the sunlight as if it had just scampered into frame. The resemblance was so uncanny that within hours, forums lit up with claims of a living creature caught mid-scuttle, or at the very least, a fossilized relic of Mars' prehistoric past. But as with so many Martian mysteries, the truth is less about aliens and more about the artistry of erosion. What makes this rock so convincingly lizard-like isn't biology, it's physics. Mars' atmosphere may be thin, but its winds are relentless, carrying fine dust particles that act like nature's sandpaper. Over millennia, these particles sculpt exposed rock into fluid, organic shapes, polishing some surfaces while undercutting others. The lizard is likely a ventifact, a wind-carved stone shaped by persistent abrasion from a single prevailing direction. On Earth, ventifacts in deserts like Antarctica or the Mojave take on similar streamlined forms, though rarely with such eerie anatomical precision. But Mars' lower gravity and lack of vegetation allow for even sharper, more delicate features. That glossy sheen, just the result of wind buffing the rock's surface to a near-metallic finish. Yet the lizard's popularity isn't just about geology, it's about psychology. Our brains are primed to spot animals. It's an evolutionary holdover from when detecting predators meant survival. This tendency, called Pareidolia, explains why we see faces in toast or dragons in clouds. On Mars, where every landscape feels alien, that instinct goes into overdrive. A rock that might barely register on Earth becomes a reptilian mirage under the red planet's stark lighting. Even knowing the science, part of us wants it to be real. That tension between logic and imagination is what keeps these sightings alive long after they're debunked. Conspiracy theories, of course, took the lizard and ran. Some insisted NASA had censored follow-up images they hadn't. Others claimed it was proof of a government alien cover-up despite the rock being roughly the size of a walnut. The irony, the same winds that carved this creature also erased it. By the next Martian year, the lizard had crumbled, not slinked away, just succumbed to the same forces that created it. A fleeting masterpiece of erosion, here one moment and dust the next. The lizard rock's legacy isn't about proving life on Mars. It's a testament to how effortlessly the red planet mirrors our myths back at us. Every wind-weathered ridge becomes a spine, every shadow a lurking figure, and maybe that's the real magic. Mars doesn't need monsters to be fascinating. Its natural wonders are strange enough if we're willing to look past the illusions and let the planet speak for itself. The Martian poles hold some of the most surreal landscapes in the solar system, and one particular illusion has fooled even seasoned observers. For years, satellite images of the red planet's polar regions have revealed strange, dark streaks fanning across the icy terrain, their branching patterns eerily reminiscent of trees sprouting from the frozen ground. From a distance, the effect is stunning, what looks like sprawling forest stretching toward the horizon, defying Mars' reputation as a barren wasteland. But as with so many Martian mysteries, the truth is both simpler and more fascinating than fiction. These aren't vegetation, they're nature's sleight of hand, cascades of dust tumbling down slopes of carbon dioxide ice in a spectacle that reveals just how dynamic Mars' frozen poles truly are. The phenomenon occurs when seasonal sunlight warms the translucent CO2 ice, causing it to sublimate, transform directly from solid to gas, just beneath the surface. As pressure builds, trapped gas bursts through weak spots in the ice, launching geysers of fine dust that darken the surface. When this happens on sloped terrain, gravity takes over, sending the loosened material sliding downward in rivulets that mimic the fractal patterns of tree branches. The illusion is so convincing because it taps into our brain's instinct to recognize familiar shapes. Just as we connect dots to form constellations or sea faces in clouds, our visual cortex interprets these streaks as something alive, a quirk of perception called pareidolia. What makes these trees more than just a curiosity is what they reveal about Mars' active geology. Unlike Earth's relatively static ice caps, Mars' polar regions are constantly reshaped by seasonal changes. The same process that creates the trees also sculpts other bizarre features, spider-like channels carved by escaping gas, or Swiss cheese terrain where circular pits dot the ice. This isn't a dead landscape, it's a laboratory for exotic physical processes we rarely see on Earth. The trees are just one visible heartbeat in a much larger planetary cycle. The illusion also highlights a deeper tension in how we explore Mars. Every time we project Earth-like imagery onto its terrain, whether trees, faces, or crabs, we risk overlooking the planet's true strangeness. Those dark streaks aren't failed forests, they're evidence of a world where ice behaves like rock, where dust flows like liquid, and where the rules of geology rewrite themselves under a pale pink sky. The Mars trees may not be alive, but the planet that creates them certainly is, and that's a reality far more thrilling than any mirage. Among the jagged rocks and wind-scoured boulders of Mars, one discovery stood out like a cosmic billiard ball, an almost impossibly round sphere nicknamed the Mars Cannonball. When Curiosity rover rolled up to this perfect orb in 2016, it seemed to defy the chaotic landscape around it. Unlike the irregular stones littering the Martian surface, this rock was so meticulously spherical it could have rolled straight out of a factory. Scientists quickly identified it as a concretion, a hardened lump of minerals formed when water percolates through sediment, depositing layers of material around a central core. But what's fascinating isn't just what it is, it's how it got so absurdly round. On Earth, we see similar formations like the Moqui marbles of Utah, nickel-sized spheres of sandstone cemented by iron oxide, scattered across the desert like nature's own ball bearings. These form over millennia as groundwater carries dissolved minerals, slowly building concentric layers around a speck of organic matter or a grain of sand. Mars Cannonball likely shares this origin story, a relic from a time when liquid water still flowed across its surface. But here's the twist: Martian concretions are flawless in ways Earth's rarely are. Without rain, rivers, or tectonic activity to disrupt their growth, they're free to develop in undisturbed perfection, like pearls forming in still water. Yet even among concretions, this cannonball is an outlier. Most are lumpy or slightly oblong, their shapes betraying the messy chemistry of their birth. This one, though, it's a geometric marvel, its surface smoothed by eons of gentle abrasion from Martian winds. Some researchers speculate that lower gravity and thinner air might allow for more uniform erosion, sanding down edges with freakish precision. Others wonder if the mineral composition, possibly hematite, like the infamous Blueberries, gave it extra durability against weathering. Of course, no Martian mystery would be complete without a dash of wild speculation. The cannonball's unnatural symmetry has fueled theories ranging from ancient Martian sports, interplanetary box, anyone, to debris from an alien craft. Skeptics chuckle, pointing out that nature adores spheres, from planets to bubbles to raindrops, so why wouldn't rocks follow suit? Still, the cannonball's eerie perfection lingers in the imagination, a reminder that Mars doesn't just replicate Earth's geology. It refines it, polishes it, and occasionally leaves us staring at a rock that feels too perfect to be random. Whether a quirk of chemistry or a cosmic wink, one thing's certain: in a landscape of jagged edges, the cannonball stands, or rather rolls, as a monument to Mars' ability to surprise. Mars loves to tease us with architecture, or at least the illusion of it. In 2022, Curiosity rover captured an image that sent conspiracy theorists into overdrive. A near-perfect rectangular notch carved into a cliff face, its edges so crisp and angular it looked like a doorway straight out of a sci-fi epic. The internet collectively gasped had we stumbled upon a Martian stargate, the entrance to an underground city, or just the universe's most elaborate cosmic prank. Geologists, of course, had a more down-to-earth explanation. Mars' bedrock is riddled with fractures, and over eons, stress forces can cause rocks to split along straight lines, creating geometric cracks. On Earth, we see this in places like Utah's canyonlands, where sheer cliffs fracture into grids of near-perfect rectangles. The doorway is just one of these fractures, albeit one that happens to be photogenically framed by shadow and perspective. From another angle, it's clearly just a shallow alcove, barely deep enough to hide a house cat, let alone an interdimensional portal. But here's where the fun begins. The doorway's precision isn't just a fluke. It's a testament to Mars' unique geology. Without plate tectonics or Earth's relentless erosion, fractures can remain startlingly pristine for billions of years. Wind polishes the edges, dust fills the gaps, and voila! Nature sculpts a masterpiece that looks engineered. It's the same phenomenon that creates the planet's infamous pyramids and stairs, rocks so geometrically perfect, they fool us into seeing design where there's only chaos. That said, let's indulge the Stargate fantasy for a moment. Imagine if it were a doorway. Where would it lead? To a buried civilization, a secret NASA base? Spoiler, no. The charm of these Martian mirages isn't in their reality, it's in the stories they inspire. Every artifact we spot reflects our hunger for connection, for a universe that feels less empty. And Mars, with its silent cliffs and whispering winds, is the perfect canvas for those dreams. So while the doorway is just a crack in a rock, it's also a mirror. It shows us how desperately we want Mars to be weird, to be alive, to be more. And in a way it is, just not in the ways we expect. The real magic isn't in fake doorways, but in the very real mysteries still waiting behind them. Who needs aliens when you've got a planet this good at keeping secrets? Among Mars' endless gallery of bizarre rocks, one stands out for its uncanny resemblance to a forgotten breakfast, a peculiar formation dubbed the Martian Waffle. When Opportunity rover trundled across the planet's Meridiani Planum in 2014, its cameras locked onto a rock so geometrically precise it seemed etched by an otherworldly chef. The surface was crisscrossed with a near-perfect grid of ridges, each intersection forming tidy, right-angled corners. The internet predictably lost its collective mind. Was this fossilized alien architecture the remnants of a cosmic kitchen, or just another case of Mars trolling us with its geological pranks? Scientists had a more grounded explanation: mineral veins. On Earth, similar patterns form when water rich in dissolved minerals seeps through cracks in rock. Over time, the minerals solidify into veins harder than the surrounding stone. When softer rock erodes away, whether by wind, water, or time, the tougher veins remain, leaving behind a latticework of raised lines. On Mars, where winds scour the surface like a sandblaster, this process can create almost unnervingly regular grids. The Waffle rock is essentially nature's stencil, a snapshot of fluid dynamics frozen in stone. But here's what makes this formation extra weird. Most mineral veins on Earth twist and branch organically, following the chaotic paths of fractures. This Martian specimen, though, boasts a grid so uniform it could have been drafted with a ruler. Some researchers speculate that Mars' lower gravity and lack of tectonic activity allow fractures to propagate in straighter lines, creating freakishly orderly patterns. Others wonder if the rock's composition, possibly sulfate minerals known to form boxy crystals, gave it an extra edge in geometric precision. Either way, the Waffle rock isn't just a curiosity. It's a masterclass in how alien geology can mirror human craftsmanship. Of course, the Waffle's viral fame isn't just about science, it's about delight. There's something irresistibly whimsical about a planet serving up rocks that look like brunch. Memes erupted overnight, from Mars Pancake House logos to jokes about rover picnics. NASA leaned into the fun. tweeting a tongue-in-cheek reminder that opportunity wasn't equipped with syrup dispensers. And that's the magic of these moments. They remind us that exploration isn't just about data. It's about wonder, about stumbling across something so joyously silly that it bridges the gap between distant planets and our everyday lives. Yet beneath the humor lies a serious truth. The Waffle rock, for all its breakfast-themed charm, is a clue to Mars' watery past. Those mineral veins likely formed billions of years ago when liquid water still pooled on the surface. They're fingerprints of a time when Mars might have been as hospitable as Earth, a world of rivers, lakes, and maybe even life. So while we laugh at the idea of interplanetary waffles, we're really marveling at a planet that keeps rewriting its own history, one strange rock at a time. The grid on that stone isn't just a quirk, it's a message from ancient Mars waiting patiently for us to decode its recipe. Mars has given us face-like formations, doorway-shaped cracks, and even rocks that resemble breakfast foods, but perhaps none are as playfully unsettling as the so-called Mars Yeti footprint. In 2019, the Mars Reconnaissance Orbiter spotted a peculiar depression in the planet's Arabia Terra region, a deep, rounded imprint stretching nearly a kilometer across, with what appeared to be 5 toe-like ridges at one end. The resemblance to a colossal footprint was so striking that even scientists couldn't resist the comparison. The internet naturally went straight for the mythos. Had some ancient titanic creature once stomped across the Martian plains, leaving behind a fossilized stride frozen in time? Geologists, of course, have more grounded explanations. The leading theory suggests this footprint is actually a collapsed impact crater, one where the rim eroded unevenly over time, leaving behind a distorted but vaguely organic shape. Mars' thin atmosphere and relentless winds can sculpt craters into bizarre forms, undercutting some edges while preserving others. Alternatively, it could be a pit formed by volcanic activity, where sinking lava tubes or collapsing magma chambers left behind a depression that erosion later exaggerated. Either way, nature has a flair for drama, turning ordinary geology into something that tickles our primal instincts. But let's indulge the Yeti theory for a moment. Imagine a Martian cryptid towering over the landscape, its weight compressing the rust-colored soil with each step. The idea isn't just fun, it's a window into how humans project stories onto the unknown. On Earth, we've done the same with everything from Bigfoot to the abominable snowman, attributing strange marks in the wilderness to creatures lurking just out of sight. Mars, with its eerie silence and untouched terrain, amplifies that impulse. Every shadow becomes a lurking figure, every dent in the soil feels intentional. The real charm of the Yeti footprint lies in its duality. It's a scientific case study in planetary erosion and a cultural Rorschach test. For researchers, it's a clue to Mars' violent past, where impacts and volcanic forces shape the surface in ways we're still deciphering. For the rest of us, it's a reminder that exploration isn't just about data, it's about wonder. The best Martian mysteries don't just challenge our tools, they spark our imaginations, inviting us to see a planet that's equal parts laboratory and legend. So while the footprint isn't proof of a Martian megafauna, it is evidence of something just as compelling, our endless desire to find the extraordinary in the ordinary. Mars doesn't need Yetis to be fascinating, but it's delightful that it keeps giving us reasons to look twice. Who knows, maybe one day we'll find a mystery that does defy explanation. Until then, the footprint remains a testament to the red planet's talent for keeping us guessing and grinning. Mars has served up some strange sights over the years, but few are as delightfully perplexing as the so-called floating spoon. When Curiosity rover beamed back images of this oddity in 2017, it looked like something straight out of a cartoon, a slender, spoon-shaped rock jutting horizontally from a cliff face, perfectly balanced as if suspended by invisible strings. The illusion was so convincing that viewers could practically hear the bawling of animated physics defying reality. How could such a delicate structure survive Mars' harsh environment without crumbling? The answer lies in an elegant interplay of erosion and gravity, one that makes Mars the solar system's ultimate sculptor. What seems like an impossible balancing act is actually a masterclass in patience. Over millions of years, Martian winds have sandblasted softer rock layers away, leaving behind only the most resistant minerals. The spoon isn't floating at all. It's still attached at its base, though the angle of the photo obscures that connection. What makes it extraordinary isn't magic, but the precision of its carving. The same winds that can hurl planet-wide dust storms can also work with surgeon-like delicacy, etching fragile formations grain by grain. On Earth, similar features like Utah's famed balanced rock form through erosion, but Mars' weaker gravity, just 38% of Earth's, allows for even more precarious arrangements. Rocks that would collapse under their own weight here can linger for eons there, frozen in mid-air like cosmic illusions, the spoon's secret weapon, hematite. This iron-rich mineral, found in many of Mars' most bizarre formations, is notoriously tough. While surrounding sandstone erodes, hematite veins endure, creating freestanding structures that seem to laugh in the face of physics. But even hematite has its limits. Close inspection shows cracks spiderwebbing across the spoon's handle, a reminder that Mars' artistry is temporary. One day, maybe tomorrow, maybe in a million years, this geological masterpiece will succumb to gravity's whisper. What makes the spoon more than just a quirky rock is how it embodies Mars' contradictions. A planet of violent dust storms and crushing cold somehow crafts formations as delicate as blown glass. A world where atmosphere is barely present still wields wind like a master artist. And that's the real wonder here. Every time we dismiss Mars as a dead world, it serves up a reminder: even in stillness there's motion, even in silence there's creation. The spoon isn't just a rock, it's a lesson in how beauty thrives in the most unexpected places. So while it may not be actual cutlery, it's certainly giving us something to chew on. Among the dust and rocks of Mars, Curiosity rover once stumbled upon something delicate, something almost alive. In 2022, its cameras zoomed in on a tiny, flower-like structure no larger than a penny, its fragile petals splaying outward as if frozen mid-bloom. The internet swooned. Had we found Martian flora, a fossilized remnant of some ancient alien garden? The truth, as always, is a beautiful marriage of chemistry and illusion. This Mars flower isn't biology, it's mineralogy at its most poetic. Scientists believe it's a type of diagenetic crystal cluster, a formation that occurs when minerals like gypsum or calcium sulfate precipitate out of water, growing slowly in the spaces between grains of sediment. On Earth, we see similar structures in caves as stalactites or in deserts as desert roses, bloom like aggregates of selenite crystals. Mars' version likely formed billions of years ago when groundwater rich in dissolved minerals seeped through porous rock. As the water evaporated or chemical conditions changed, these intricate crystalline fingers grew, layer by microscopic layer, until wind erosion exposed them like a sculptor revealing a masterpiece. What's mesmerizing isn't just the flower's origin, it's the uncanny resemblance to life. The way those mineral tendrils curve and branch mirrors organic growth patterns, a phenomenon called biomorphism where non-living processes mimic living ones. It's nature's inside joke, chemistry aping biology so perfectly, it fools even seasoned scientists at first glance, and that's the heart of the intrigue. Every time Mars serves up something that looks alive, whether a flower, a face, or a femur, it forces us to confront our own biases. We're so wired to seek life that we see it everywhere, even in the silent clinking of atoms. But here's the twist. While the flower isn't proof of life, it is a clue to Mars' hidden potential. Those delicate crystals couldn't have formed without water, lots of it, and the right chemical soup. They're tiny time capsules from an era when Mars might have been warm and wet, a world where conditions could have nurtured life, and that's the real gift of this flower. It's a reminder that Mars' past was lush with possibility, even if its present is a frozen desert. So next time you see that fragile, crystalline bloom in the rover's images, don't just dismiss it as a trick of geology. Marvel at the fact that a planet so harsh can still birth something so tender. Mars may not have gardens, but it crafts its own kind of beauty, one mineral petal at a time. Mars has a way of making even geology feel like myth, and nowhere is that more evident than in the so-called dragon scales terrain. Stretching across vast plains near the planet's equator, this bizarre landscape looks like something ripped from a medieval fantasy. Endless overlapping plates of rock, each ridged and upturned at the edges, creating the illusion of a gargantuan serpent slumbering beneath the dust. The patterns are so precise, so intentional, that it's hard to believe wind and time alone could carve such artistry. But here's the twist: this isn't the work of mythical beasts, it's a puzzle that has geologists torn between two fiery origins. One camp argues these scales are the fossilized remnants of ancient mud cracks. Picture a shallow lakebed billions of years ago, its surface drying under a fading sun, contracting into polygonal fractures as the last puddles evaporated. Over eons, these cracks filled with wind-blown sediment or mineral-rich groundwater, hardening into ridges tougher than the surrounding mudstone. Later, erosion stripped away the softer material, leaving behind the raised scales we see today. It's a process we've watched play out in places like Death Valley or Namibia. Just on a scale Mars takes to the extreme, the other faction points to lava. Mars was once a volcanic powerhouse, and as molten rock spread across its surface, it could have cooled unevenly, fracturing into plates that buckled and curled as they contracted. Similar formations appear in Earth's lava fields, like Iceland's Helluron, where ropey Pahoho lava forms undulating, scale-like textures. On Mars, lower gravity and thinner air might amplify these effects, creating more pronounced, dramatic ridges. Add a few million years of dust settling into the crevices, and voila, dragon armor. But what makes this terrain truly mesmerizing isn't just the science, it's the spectacle. Sunlight raking across the ridges casts long, sinuous shadows that seem to ripple as the planet rotates, enhancing the illusion of movement. From orbit, the effect is dizzying. You half expect the ground to rear up and take flight. It's a reminder that Mars doesn't just have geology, it performs it, turning mundane processes into theater. The dragon scales also whisper tantalizing hints about Mars' climate history. If they're mud cracks, they bolster the case for a wetter, warmer past. If they're lava, they map the fury of the planet's volcanic youth. Either way, they're proof that Mars' story is written in its rocks, not in ink, but in fire and water and time. So while there's no actual dragon lurking beneath the dust, the truth might be just as magical. A world that sculpts its own legends, one scaly ridge at a time. Imagine this: you're scrolling through Mars photos when suddenly there it is. A sleek, angular shadow darting across the rusty terrain, its elongated silhouette unmistakably artificial against the natural chaos of rocks and dunes. For a split second, your pulse quickens. Is this it? The smoking gun proof of extraterrestrial visitors we've been waiting for? Then reality kicks in. That's not an alien spacecraft, it's the shadow of Ingenuity, NASA, a plucky little helicopter, making history as the first aircraft to ever fly on another planet. This exact scenario played out in 2021 when raw images from Perseverance rover's cameras captured Ingenuity mid-flight, its shadow stretching across Jezero crater like something out of a sci-fi flick. The internet, ever eager for cosmic intrigue, lit up with theories. Some swore it was a UFO deliberately caught on camera. Others claimed NASA was testing secret Martian drones. The truth, though, even cooler. Ingenuity's shadow became an accidental Rorschach test, a perfect example of how human technology on Mars keeps sparking new myths. Here's the irony: we sent Ingenuity to demystify Mars. This 4-pound rotorcraft was designed as a scout, zipping ahead of Perseverance to map terrain too rough for the rover to traverse. Every flight was a triumph of engineering, proving powered flight was possible in Mars' wispy atmosphere, just 1% as thick as Earth's. Yet instead of just marveling at the science, we projected our oldest extraterrestrial fantasies onto its shadow. Why? Because Mars transforms everything it touches into a mystery. A rock becomes a face, a crack becomes a doorway, and now a helicopter becomes a UFO. The phenomenon taps into something deeper about how we explore. Every tool we land on Mars, from rovers to helicopters, becomes an extension of our senses, but also a Rorschach blot for our imaginations. When Viking's lander arm left tracks in the dust, some saw proof of NASA staging footage. Curiosity's tire treads, obvious cover-ups for secret bases. With Ingenuity, we've entered a new era, one where our own creations are so alien in context they feel extraterrestrial. A helicopter on Earth is mundane. That same silhouette on Mars, suddenly it's otherworldly. But there's a lesson here beyond misidentification. Ingenuity's shadow and the myths it spawned reveals how alive Mars feels to us. We don't just see a helicopter, we see movement, agency, something that doesn't belong. That cognitive dissonance is what makes the red planet so endlessly fascinating. Even as we litter its surface with our machines, Mars retains its aura of the unknown, turning our own tools into ghosts in the machine. So next time you spot a strange shadow in a rover image, ask yourself, is it a sign of aliens or just humanity casting a very long shadow on a planet that refuses to be fully known? Mars never runs out of ways to make us do a double take, and one of its most convincing illusions appeared in 2021 when Perseverance rover spotted a rock that looked like it belonged in a natural history museum. There, half buried in the dust of Jezero crater, lay what seemed to be a fossilized whale vertebra, its curved, segmented form eerily reminiscent of Earth's ancient marine giants. The resemblance was so striking that for a moment it was easy to forget one glaring problem. Mars has never had oceans deep enough or ecosystems complex enough to support creatures of that scale. But that's the magic of Pareidolia. Our brains are so finely tuned to spot familiar shapes that we'll project them onto anything, even a desolate alien landscape where the closest thing to a whale is a wandering dust devil. What makes this whale bone rock more than just another optical illusion is the tantalizing possibility it hints at. While we know Mars had liquid water billions of years ago, evidenced by dried-up river deltas like Jezero itself, the idea of a marine ecosystem big enough for whales stretches credulity. But here's the twist: if we did find fossils on Mars, they wouldn't be towering skeletons. They'd be microscopic. On Earth, some of the oldest signs of life are stromatolites, layered mounds built by ancient bacteria in shallow water. If Mars ever hosted life, traces might look similar. Subtle textures in rock, chemical imbalances, or chains of carbon atoms arranged in telltale patterns. The whale bone is a red herring, sure, but it's also a reminder that the real fossils we're hunting could be hiding in plain sight, too small for the naked eye. And that's where the science gets thrilling. Perseverance isn't just snapping photos, it's collecting samples for eventual return to Earth, where labs can scrutinize them for biosignatures. Jezero crater was chosen precisely because it once held a lake, making it prime real estate for fossilized microbes. The rover's instruments have already detected organic molecules, though these could stem from non-living chemistry. The whale bone rock, for all its organic mimicry, is likely just a weathered volcanic fragment or sandstone nodule, sculpted by wind into something that tickles our primal pattern recognition. But the fact that we're even having this debate speaks volumes. Every time we mistake a rock for a relic, we're rehearsing for the day we might find the real thing. So while the whale is just another Martian mirage, it crystallizes a profound truth about exploration. We're drawn to these illusions because they mirror our deepest hopes, that Mars wasn't always a wasteland, that life isn't a fluke confined to Earth, and that somewhere in those rust-colored rocks, there's a story waiting to rewrite biology itself. The whale bone isn't that story, but it's a placeholder, a stand-in for the discoveries that might still lie ahead. And until then, it's a testament to Mars' greatest trick, making us see ghosts of Earth in a world that's utterly, magnificently alien. Mars doesn't just play tricks with shadows and faces sometimes, it serves up a cosmic curveball, or in this case, a golf ball. In 2021, Perseverance rover rolled up to a rock so uncannily spherical and dimpled, it looked like it had been plucked straight from a driving range. The internet, never one to resist a playful theory, immediately ran with the idea of Martian mini-golf, a proof, perhaps, of a civilization that took its leisure time very seriously. But as with so many of Mars' quirks, the truth lies in the artistry of erosion, not extraterrestrial pastimes. This golf ball is a textbook example of a phenomenon called spheroidal weathering. On Earth, we see it in places like Alabama's Rock Garden, where boulders weather into near-perfect spheres. Here's how it works. When rock forms, it's often riddled with tiny cracks and fractures. Over time, water, or in Mars' case, wind-driven sand, seeps into these weak points, wearing away the edges first. The process is like nature's own lathe, chiseling rough stone into smooth orbs. The dimples, those are pockets where slightly harder minerals resisted erosion, leaving behind pockmarks that just happen to mimic the aerodynamic divots of a tight list. But Mars adds its own twist to this recipe. With gravity only a third of Earth's, wind-blown particles can sandblast rocks with freakish precision, sculpting surfaces that feel almost machined. The golf ball's uncanny symmetry might also hint at its composition. Rocks rich in olivine or basalt, common on Mars, tend to fracture in concentric layers, making them prime candidates for this kind of weathering. It's geology's version of a snowball rolling downhill. Start with a few uneven edges, and given enough time, you'll end up with a sphere. Of course, the golf ball's viral fame isn't just about science. It's about the sheer joy of seeing something so familiar in a place so alien. Memes erupted overnight, from Jezero Country Club logos to Rover selfies teeing off. Even NASA, a social team, couldn't resist a pun, tweeting that Perseverance had found the rough. But beneath the humor lies a subtler truth. These moments of whimsy bridge the gap between Earth and Mars, turning a distant world into something relatable. A golf ball isn't just a rock, it's an invitation to imagine ourselves there, laughing under a pink sky as we chip shots into a crater. Yet the golf ball's real value isn't in daydreams, it's in the clues it offers. Rocks shaped like this are time capsules, their smooth surfaces recording millennia of wind patterns and climate shifts. Every dimple is a tiny archive, a record of how Mars' atmosphere, thin as it is, still has the power to reshape the landscape grain by grain. So while it may not be evidence of interplanetary PGA tournaments, it is proof that Mars, for all its stillness, is a world in motion where even the rocks are playing the long game. Mars never runs out of ways to make us question reality, and one of its most convincing illusions appeared when Curiosity rover stumbled upon what looked like a crashed UFO. There, lying across the ruddy soil like a discarded spacecraft, was an elongated, metallic-looking rock with unnervingly smooth edges and a tapered shape straight out of a sci-fi flick. The internet erupted. Had aliens suffered a Martian fender bender? Was this the cover-up of the century? The truth, as always, is a masterclass in how Mars sculpts its own myths. This so-called fallen alien craft is actually a ventifact, a rock meticulously carved by the planet's relentless winds. Over millennia, sandblasting particles have sanded its surfaces to a near-metallic sheen, polishing some faces while undercutting others to create that eerie aerodynamic silhouette. On Earth, we see similar wind-sculpted rocks in deserts like the Atacama or Namibia, but Mars' weaker gravity and thinner atmosphere allow for even more dramatic forms. The rock's elongated shape suggests it once lay parallel to prevailing winds, letting abrasion work like nature's own lathe, turning jagged stone into something that looks almost manufactured. Of course, no Martian mystery would be complete without a dash of conspiracy. UFO enthusiasts pounced on the rock's uncanny symmetry, pointing to its seam-like ridges as potential proof of engineering. Some even speculated it might be debris from a secret human mission, despite NASA rovers being the only human-made objects in the area. The funniest twist. This isn't even Mars' first crashed UFO. In 2016, another rover spotted a similarly sleek rock nicknamed the Mars Magic Carpet, proving the planet has a habit of trolling us with geological doppelgangers. What makes this ventifact so special isn't just its UFO mimicry, it's the way it plays with scale. From the rover's perspective, the rock looks like it could be the size of a sedan. In reality, it's barely larger than a loaf of bread. Mars' lack of familiar landmarks, no trees, no buildings makes judging distances and sizes maddeningly difficult, amplifying the illusion. That metallic glint, just sunlight bouncing off wind-polished hematite or basalt, minerals common on the red planet. The real magic here lies in the duality of discovery. Scientists see a textbook example of aeolian erosion, a clue to Mars' atmospheric history. The rest of us see a cosmic inside joke, a planet that keeps serving up rocks just barely too perfect to dismiss outright. And maybe that's the point. Mars doesn't need aliens to be fascinating. Its natural artistry is strange enough. So while this UFO is just a rock, it's also a reminder. The line between science and science fiction is thinner than the Martian atmosphere. And honestly, we wouldn't have it any other way. Among all the craters scouring Mars' surface, one stands out not for its size or depth, but for its uncanny resemblance to life. Nestled in the planet's northern lowlands is the so-called Mars Tadpole, a crater so bizarrely shaped it looks like it could wriggle off the map. Unlike the typical bowl-shaped impacts we're used to seeing, this one stretches into a long, graceful tail, giving it the silhouette of a cosmic amphibian frozen mid-swim. At first glance, you'd be forgiven for wondering if some ancient Martian pond once held creatures that left their imprint in stone. But the truth is even wilder. This tadpole wasn't born from biology, it was sculpted by violence. The secret lies in the angle of impact. Most craters form when asteroids strike a planet head-on, blasting symmetrical holes into the surface. But when a space rock approaches at a shallow angle, less than 15 degrees, things get messy. Instead of punching straight down, it skims like a stone across a pond, carving an elongated depression with a raised rim at the leading edge and a tail of debris fanning out behind. Earth has a few examples of these oblique impacts, like Arizona's meteor crater, but Mars' thinner atmosphere lets smaller asteroids reach the surface intact, creating more extreme and dramatic shapes. The tadpole's tail stretches nearly 3 times the diameter of its main crater, a testament to the asteroid's glancing blow. But what makes this crater truly special isn't just its shape, it's the story it tells about Mars' past. The tail's smooth, channel-like appearance suggests the impact happened in an area once rich in water or ice. When the asteroid struck, the heat of the collision likely melted subsurface ice, sending a slurry of mud and debris sliding downhill to form that sinuous trail. It's a snapshot of 2 catastrophes in one: the violence of the impact and the chaotic aftermath of liquid water flowing across the surface. Some researchers even speculate that the tail might hide clues about Mars' ancient climate, preserving minerals or textures that only form in wet environments. Of course, no Martian mystery would be complete without a dash of the surreal. The tadpole's playful shape has inspired everything from memes about Martian fossils to earnest debates about Pareidolia's grip on our imagination. It's a reminder that Mars doesn't just bombard us with data, it sparks wonder, blurring the line between geology and art. Every time we map another crater, we're not just cataloging scars, we're reading a story written in fire and ice. And the tadpole, it's one of the most poetic chapters yet, a cosmic accident that somehow feels alive. Of all the strange shapes Mars has conjured, few have captured attention quite like the so-called Martian starfish. Nestled in the dust of Gale Crater, this bizarre rock formation appeared in Curiosity rover's feed in 2021 with 5 near-perfect lobes radiating outward like the arms of a celestial sea creature. The symmetry was so precise, so organic, that social media instantly lit up with theories. Was this a fossilized alien specimen? Proof of some long-lost marine past on the red planet? The truth, as always, lies in the silent artistry of erosion, but not before Mars gave us another masterclass in cosmic illusion. What makes the starfish rock so mesmerizing isn't just its shape, it's the process that created it. Geologists point to a phenomenon called differential weathering, where varying mineral hardness within a rock lets wind and dust sculpt it unevenly. Imagine a lump of Martian sandstone riddled with cracks, some filled with tougher minerals like hematite. Over eons, softer material erodes faster, leaving behind the more resistant veins in raised relief. The result, a spiky, almost floral pattern that happens to mimic Earth's starfish, a fluke of physics, not biology. On Earth, we see similar formations in places like Utah's canyonlands, where cross-bedded sandstone weathers into surreal, undulating fins. Mars, with its thinner atmosphere and weaker gravity, just takes the artistry further, carving details so fine they feel intentional. But here's what elevates this rock from geological quirk to viral sensation: its accidental beauty. The lobes aren't just randomly jagged, they're arranged in near-perfect radial symmetry, a rarity even for ventifacts. That symmetry taps into something primal in us, echoing the 5-pointed patterns found everywhere from starfish to sand dollars to cherry blossoms. It's biomimicry at its most poetic, a rock that mirrors life without a hint of DNA. And that's the real magic. Mars didn't set out to sculpt a starfish, it just stumbled into a shape that feels designed, reminding us how often nature repeats its own motifs across worlds. Of course, no Martian mystery would be complete without a dash of conspiracy. Some theorists insisted the starfish was too symmetrical to be natural, arguing it must be debris from an ancient civilization or even a petrified organism. Scientists counter that wind currents, especially in crater basins like Gale, can create astonishingly regular patterns over time. The rover's chemical analysis sealed the deal. No exotic materials, just iron oxides and sulfates, the usual Martian suspects. Yet even debunked, the starfish lingers in imagination, a testament to how effortlessly Mars blurs the line between geology and art. What makes this formation more than just a curiosity is what it reveals about perception itself. We're drawn to symmetry because it signals order in chaos, a fingerprint of life or intelligence. Mars, with its barren landscapes, offers few such comforts. So when a rock like this appears, it's like the planet tossing us a bone, letting us glimpse something familiar in the alien. The starfish isn't proof of life, but it is proof of something just as compelling, a universe that keeps rearranging its building blocks into shapes that whisper, "Look closer." And in that whisper lies the real thrill of exploration, not just finding answers, but learning how to love the questions. Deep in the Martian highlands, nestled among the dusty plains, lies a formation that looks like it was ripped straight from a fantasy novel, the eerily precise Mars Keyhole. Captured by orbiters in stunning detail, this near-perfect depression features a circular chamber connected to a long, narrow corridor, resembling an ancient keyhole carved into the planet's flesh. The symmetry is so unsettling that it's easy to imagine some cosmic locksmith designed it, or worse, that it's the entrance to a subterranean realm straight out of sci-fi lore. But before we jump to interdimensional portals, let's dig into the real forces that might have sculpted this bizarre landmark. The leading theory: collapsed lava tubes. Mars is riddled with evidence of its volcanic past, from Olympus Mons, the solar system's tallest volcano, to vast plains of frozen magma. When molten rock flows underground, it can leave behind hollow tunnels as the surface cools and the lava drains away. Over time, the roof of these tubes weakens and sections cave in, creating skylights, or in this case, a keyhole-shaped pit. Earth has similar features like Hawaii's Thurston lava tube, but Mars' lower gravity allows for far larger and more stable caverns. The keyhole's elongated neck could mark the path of an ancient lava channel, with a circular chamber representing a chamber where magma pooled before bursting through. But here's where it gets wilder. Some researchers propose the keyhole might be a pit crater, a type of depression that forms not from lava tubes, but from the sudden collapse of underground voids. On Mars, these voids could have been created by escaping groundwater or even CO2 gas, leaving behind pockets that later imploded. The keyhole's crisp edges suggest a relatively recent collapse, geologically speaking, as wind erosion hasn't yet softened its silhouette. If that's true, it raises a tantalizing question. What else is hiding beneath the surface? Of course, no cosmic oddity would be complete without a touch of myth-making. The keyhole's uncanny resemblance to a sci-fi stargate, think Stargate's ancient rings or Doctor Who's dimensional rifts, has fueled endless speculation. Could it be an artificial structure, a relic of some lost civilization? Even the most skeptical minds admit the visual parallels are striking. But that's the magic of Pareidolia at work again. Our brains are wired to see purpose in patterns, especially ones that echo our stories. The keyhole's real significance, though, isn't in its fictional echoes, it's in what it reveals about Mars' hidden depths. If this is a lava tube skylight, it could be a gateway to underground habitats, shielded from radiation and extreme temperatures. Future colonists might one day repurpose such caverns as natural shelters. Or, if it's a pit crater, it could expose layers of ice or minerals that hold clues to Mars' watery past. Every strange formation like this is a reminder Mars isn't just a desert, it's an archive, a puzzle, and maybe even a refuge, all wrapped in a landscape that keeps daring us to look closer. So while the keyhole might not unlock a portal to another dimension, it just might hold the keys to understanding this one. Mars has saved one of its most theatrical illusions for last, a wind-carved sentinel so striking, Egypt's Great Sphinx would nod in recognition. Perched on a rocky outcrop in the Red Planet's equatorial region, the so-called Mars Sphinx stares silently across the barren landscape, its flat face and arched back mirroring Earth's most iconic monument with spine-tingling precision. The resemblance isn't just uncanny, it feels deliberate, as if some ancient Martian civilization paid tribute to human mythology millennia before we existed. But like so many of Mars' riddles, the truth is a masterclass in how erosion and imagination conspire to fool us. This geological doppelganger owes its existence to a process called differential erosion, where layers of soft and hard rock wear away at uneven rates. Picture a cliff face of Martian sandstone, its strata varying in density due to ancient volcanic ash or mineral deposits. Over eons, dust-laden winds sandblast the softer layers into submission, leaving behind stubborn ridges of more resistant stone. The Sphinx's face might be a chunk of hematite-rich rock that outlasted its surroundings, while the body could be a sloping deposit of compacted volcanic sediment. Add a dash of shadow at just the right angle, and voila, a monument emerges from chaos. Yet what makes this formation more than just another case of pareidolia is its cultural weight. The Great Sphinx of Giza has loomed over human consciousness for 5,000 years, a symbol of mystery and forgotten knowledge. When we project that imagery onto Mars, we're not just seeing a rock, we're enacting a primal ritual, bridging the gap between our world and the unknown. It's no coincidence that we named this formation after Earth's most enigmatic guardian. Mars has become a canvas for our collective myths, a place where geology and legend blur. The irony, while Egypt's Sphinx whispers of humanity's past, Mars' version speaks to our future. Every time we spot something familiar in its alien landscapes, whether faces, doorways, or mythical beasts, we rehearse for the day we might find truly unnatural shapes there. It's a harmless game until it isn't. In 1976, Viking orbiters' face on Mars sparked conspiracy theories that persist today, proving how quickly wonder can curdle into mistrust. The Mars Sphinx walks that same tightrope, daring us to marvel without tipping into delusion. And that's the real lesson here. Our knack for seeing Earth in Mars isn't a flaw, it's a feature. Evolution hardwired us to seek familiar patterns in the unknown, a survival tactic that now colors our cosmic curiosity. The Sphinx rock isn't just wine-sculpted stone, it's a Rorschach blot for our dreams of connection. As we inch closer to boots on Martian soil, we'll doubtless find more statues, temples, and artifacts hiding in plain sight. The challenge won't be ignoring them, it'll be knowing when to laugh at the illusion and when to ask, against all odds, what if this time it's real? So here's to the Mars Sphinx, a trick of light and time, a mirror for our myths, and a fitting finale to the Red Planet's gallery of enigmas. It reminds us that exploration isn't just about mapping terrain, it's about navigating the uncharted territory between what we see and what we long to see. And if Mars keeps blurring that line with rocks that wink back at us, well, that's the kind of mystery that never gets old. Mars, the red planet, has spent decades teasing us with its enigmas, from the infamous face in Cydonia to the fleeting methane spikes that could whisper of hidden life. We've wandered through valleys where rocks roll on their own, marveled at plumes that tower into space for no discernible reason, and debated whether that doorway in the cliffs is geology's prank or a genuine invitation. 30 mysteries deep, and one thing's clear: Mars isn't just a desert, it's a stage where nature performs its greatest illusions, blending hard science with irresistible myth. What makes these phenomena so captivating isn't just their strangeness, it's how they dance on the edge of explanation. Take the Recurring Slope Lineae. Are they proof of briny water or just dry avalanches playing tricks? The dragon scales terrain, ancient mud cracks or lava's fingerprint. Even the solutions split into branches, each possibility opening new questions. Mars refuses to be pinned down, and that's the magic. Every answered riddle births two more, keeping scientists and stargazers alike in a perpetual state of wonder. And the best part, we're just getting started. The Rosalind Franklin rover, launching soon, will drill deeper than ever for signs of life. The Mars Sample Return mission could bring back rocks that rewrite planetary history. Next-generation orbiters will scan for hidden water with lasers sharper than any before. Each mission is a key turning in the lock, and who knows, maybe the next big reveal is already sitting in a rover's camera roll, waiting for the right pair of eyes to spot it. But here's the real secret: these mysteries aren't just about Mars, they're about us. Every time we project faces onto cliffs or sea bones in rocks, we're revealing how desperately we crave connection in the cosmos. Mars mirrors our curiosity back at us, a celestial Rorschach test where science and imagination collide. It's not just a planet, it's a conversation, one that's been unfolding since the first humans looked up and saw that blood-red dot in the sky. So, which mystery grabs you? The methane that comes and goes like a ghost, the Waffle rock that defies erosion's chaos, or something we haven't even discovered yet? Drop your pick in the comments, because the greatest thing about Mars isn't just the questions we've asked, but the ones we've yet to dream up, and who knows? The next big discovery might